Good afternoon, everyone. Today we're going to continue our discussion on multiple linear regression. And by way of review, what we did last time was to get the uh, create a linear model where we regressed Apple returns on SPY returns. Okay, we got the data from quant mode using quant mode via Yahoo, and this was the result of our linear regression model. Okay, we are saying that your Apple returns is equal to 0.003552 plus 1.189, around 1.19 times your SPY returns. Your SPY returns, the marginal impact of SPY returns, your beta 1 is highly statistically significant, while your intercept is not significant. But nevertheless, even if the intercept is not significant, we still include that in the model. Okay, so what's the meaning of this? We're saying that for every 1% increase in the returns of SPY, we said is the ETF for GSPC, for Standard and Poor's, and it acts to mimic the market. Okay, we said that a 1% increase in SPY returns will yield a 1.19 percent increase in Apple returns. So we say that Apple returns is very sensitive to the market. Okay, a beta higher than 1. We say that it's sensitive to the market, whether it's positive or negative. If it's negative, then it moves against the market, opposite the market. Okay, and we said that there are some measures here which we looked into. We looked at multiple R squared 62.81 tells us that around 63% of the variability of your Apple returns can be explained by our model consisting of SPY returns. And what we did last time was to compute for this via the measures SST, SSR, and SSE. So let's quickly take a look at that. By the way, we plotted also this is the scatter plot for your Apple daily log returns and SPY log returns. And then we inputted here also the linear model. Okay, the slope here is around 1.19. Okay, and that tells us that for every one unit or 1% increase in your here, okay, 1% increase in your, so the slope is rise over the run. The rise is 1.19. The run is 1. For every 1% increase in Apple returns, I'm sorry, in SPY returns, Apple returns increases by 1.19, and we said that it's quite sensitive to the market, positively sensitive to the market, which means that when the market goes up, Apple goes up also. When the market goes down, Apple will also go down. Okay, we also, I think, took a look at confidence interval. Okay, but let's now let's have a review of this one. SST, we said that in order to compute for your multiple R squared, you have to know your sum of the squares total. Sum of the squares total is simply, okay, what we're doing here is we're not using SPY returns. We're just using Apple itself, the intrinsic data, because this is the difference between the specific returns, log returns of Apple minus the mean of Apple. So we're not using SPY returns here in order to compute the sum of the squares total. So the mean is a constant figure, constant number, and we subtract to the mean all your actual returns. Okay, and what we do is for each of the difference we square. So if we have 1256 observations, okay, we square each of the difference and then we sum it up. And that gives us the total sum of the squares. So which brings us now to the sum of the squares regression. Here, we're using now SPY returns in order to model Apple returns. The y hat here stands for the predicted value. And how was that generated? Using the LM function. LM of Apple returns tilde SPY returns. Okay, and the predicted value is this one. Whatever object we generated from that class, we called it, I think, model 1 or model 2, whatever we named it, we can access the predicted returns. Okay. How are the predicted returns determined or computed? Well, for the model, you're going to be given the beta null and the beta 1, the intercept and the slope. And we said that the model used is OLS, ordinary least squares, whereby we're minimizing the squares of the residuals. So here we are computing for the improvement in your model because the initial model was just the mean. Okay, so by generating the regression model, okay, we are improving on the mean itself. So y hat, the predicted value minus the average value. Once again, square it and then get the sum. Okay, so which means this will be just one figure, this will be just one figure, and this will be just one number. And the residuals class, sum of the squares of the residuals will be the difference between your actual value minus your predicted value. Okay, that's the error. Again, square that and then get the sum. And then the relationship between these three metrics are that SST plus is equal to SSR plus SSE. And if you divide everything by SST, so SST divided by SST, that's 1. And it's equal to SSR over SST plus SSE over SST. Okay, this is now your multiple R squared, or the proportion of that's the variability of your dependent variable y sub I that can be explained by the model. Our model class is we use SPY returns, right, in order to predict our Apple returns. This is your unexplained variance, SSE, error terms, cannot be explained class. So this is your explained variance. This is your unexplained variance. This is your multiple R squared. Okay, and we showed that last time. We computed for SST, SSR, and SSE and showed that indeed the explained variance is 62.81, which tallies with the regression output. Okay, now we now go to an application of our linear model, and this time we're going to look at CAPM. Okay, so let's go here. Here. Let's now go to CAPM, capital asset pricing model. So I don't think you have this. I'm going to share by piecemeal class. So kindly copy that. I'm going to copy some, but for the rest, for others, I'm going to ask you to type Control C. I hope this fits. Okay. And I'll include some more. All right. Maybe up to this one. Okay. So based on what you said before, you have discussed CAPM, at least the concept of CAPM, maybe not, maybe as very simple way to compute your capital asset pricing model. So the objective is to determine the returns of your asset, okay, the excess returns of your asset based on the excess returns of the market. So just like the one that we used previously, where we used SPY returns in order to model Apple returns. The difference between what we did last time and what we're going to do now is that we're going to use exactly what the CAPM, capital asset pricing model, calls for. Capital asset pricing model calls for the use of excess returns. So based on this formula, the expected return of the asset is equal to your risk-free rate plus your beta. So this is the slope of your excess market returns. We rearrange this, okay, where we have R sub I, this is the return of the asset, minus the risk-free rate is equal to, and then we have this intercept plus, again, the excess market returns plus your error terms. So we're structuring it in such a way that we can use it as a linear model. So this is your R sub I excess. Why excess? Because we net it against the risk-free rate. Okay, so it would be equal to your intercept, beta null, which is later on we'll call this your Jensen's alpha, plus beta 1 times the excess market returns plus your residuals. Okay, your R sub F here is the risk-free rate, and then we're going to use the U.S. Treasury bills because we're using Apple and the SPY, which are U.S. assets. Okay. So how do we estimate, class? The objective is to estimate your beta. How sensitive is your asset to the market? Okay. So beta sub I is the beta of the asset, and it measures its sensitivity to the market. If your beta is greater than 1, okay, so it means it's very volatile or very sensitive to the market. A beta of 1.5 means that if your excess market returns increases by 1%, then your excess asset returns increases by 1.5%. Okay, so these are assets that are very aggressive, like tech stocks, growth stocks. They usually have a beta, okay, that's greater than 1 relative to the market. On the other hand, there are assets where the beta is approximately equal to 1. And we say that these assets are moving alongside the market. Some assets are less than 0.5, are less than 1. So it can be, let's say, 0.4, 0.3. And this type of assets are characterized by they're less sensitive to the market or less volatile relative to the market. A beta of 0.5 means if the market moves by 1%, this asset will only move by 0.5%. Okay, so it's quite conservative and it's not as volatile as the beta greater than 1. Okay, and usually defensive stocks such as utilities, consumer staples exhibit betas that are less than 0.5, less than 0.1, less than 1 class, sorry. And then beta is equal to 0. That means that the asset is uncorrelated to the market. Example, risk-free rate class. If you plot the risk-free rate with the market, then it most probably will be a horizontal line, which means that whatever happens to the market, it doesn't move. And some assets can be negative beta, which means it moves opposite the market. And this is very good for hedging. Okay, so hedging means, class, that you put in this asset in your portfolio so that if the market goes down, okay, you have this asset that's going up on the other hand. So it acts as a hedge. And examples are put options and some commodities like gold during crisis. They exhibit negative beta, which means they move opposite that of the market. All right. So we're now going to, okay, this is just the same as above. So if the beta is, okay, let me just share this with you. And the next one, let's see. See the, okay. So we're going to use, okay, we're going to use performance analytics later because we're going to compute for alpha and beta in two ways. We're going to use the LM model, and then we're also going to use performance analytics. So let's run this. I won't run it anymore. Okay. So what risk-free rate are we going to use since we're using Apple and the SPY returns? We're going to download data from using Fred class here. And this is their debt treasury bills 3 months. So this is 3 months treasury bills. We can get that from Fred. So we're using get symbols from the quant mode package. Quant mode DTB3 source is equal to Fred. We can get this from Yahoo Finance. And then let's just peg the same beginning and same ending as our assets. 2020 0101 to 2024 1231. Auto.assign is equal to true. So run this, please. Okay, anyway, I'll just run it also. Control Enter. And then we have now, it will now create a DTB3 class. Okay. And as expected, it's an XTS object. Okay, let's run this. Okay, and you can see that there are some dates that are NAs, missing values. Okay, so this is a concern for us. It's because let's check how many missing values do we have. Later on here, I gave it to you. Okay, so let's first convert our data. The data here, according to Fred, this is annual data. Okay, this is annual data, although it's so the data here is annual. Okay, annual rates to. Of course, rates are annual class, no? And then so we have to convert it into daily data because our data class, our Apple returns and our SPY returns are daily. No? So how do we convert it? We first convert it into percent and then divide by 252 in order to convert it into daily data. Okay, so let's run this. Risk-free risk-free rate daily, and it's also an XCS object class here. So there are missing values here. These are now daily data. Okay, and the DTB3. Let's replace it by risk-free rate class. Column names of our object risk-free rate daily is equal to rf.rate. If I run this will now become rf.rate, still with the missing values. Okay, and then let's check how many missing values are there. Let's sum up all the NAs for our risk-free rate daily. And we have 54 missing values, quite a lot, class. How many observations do we have? 1,305 observations. And there are 54 missing values. Okay, let me pause for a while and ask if you're able to follow. Kindly, please, chat in the chat box. I'll give you a few seconds to run the codes. Anyway, I already gave it to you, class, so you don't need to write anything anymore. I just wait for you to respond to my query if you're able to generate DTB3, if you're able to generate risk-free rate daily, okay, and then if you were able to change the column name and then determine how many missing values there are. Okay, let's give your classmates a few more seconds. I'm only getting 4 responses, 4 out of 24. Okay, thank you. All right. I'm not getting a high response rate. I hope the others are able to follow. Okay, thank you. Okay, thank you. Okay, so what are we going to do now? So we now have an object risk-free rate daily. Okay, let me print that again. There are 1,305 observations with 54 NAs. Okay. So let's begin with the end in mind. What do we want to do? We want to create a data frame. Take note, a data frame that includes, maybe we can include RF rate, but what we want is the Apple excess returns and the SPY excess returns. Why excess returns? Because CAPM requires that the returns that we're modeling should be excess returns. So we should subtract that from the risk-free rate. Okay, not only the asset but also the market. Okay, so that's what we want. And how do we generate the excess returns, class? We subtract that from subtract it to the treasury bill rates. Okay, so if we can do Apple returns minus T-bill rates and SPY returns minus T-bill rates, then we have the excess returns. Okay, so let's do that. Now, if you recall, class, we have combined returns. Check combined returns, please. We did it last time. Okay, here. Combined returns is also an XTS object. We did this by getting the log returns, log returns of Apple and log returns ng SPY. There are 1256 observations. Okay, 1256 observations. Okay, so number 3. All right. So let's now create an object called CAPM. Okay, for this one, class, I'm only going to give you the I want you to write this code, class. So CAPM, what are we going to do? We're going to merge the combined returns, okay, combined returns with the risk-free rate plus risk-free rate. So both are XTS objects, so no problem. Okay, the problem is si risk-free rate class 1305 observations. Si combined returns has only 1256 observations. So there's a mismatch. Risk-free rate daily is longer. Okay, so there are several ways to address that. One of the easiest way is to make sure that what will be included in the data, CAPM data, has similar has the same columns. It has the same dates. Okay, and that's done by all is equal to false. So what's this class? We're combining the merge function, combining combined returns, which is Apple returns and SPY returns, with the risk-free rate. Okay. As I said here, note the assets have different observations. The all is equal to false function will delete what is not common to all. Okay. Will delete what is not common to all. And the question is this the best way to clean your data? Okay, that's a very important question. Back here, class, we have 1305 observations. Besides, may mga NA tayo, no? We have NAs. So, either, what can be done is to do LOCF. What's LOCF? The last value here, we can put it here. Okay, because that's one of the most logical thing to do. Okay, but what we're going to do now is the most simple one, which is risk-free rate daily has 1256 observations. This one has 1305 observations. Okay, so how do we do the mismatching? The simplest way to do it is all is equal to false, which means that what is found in in both should be included. What should be found in both? So which means that those dates that are available in risk-free rate daily, 1305 all in all, will not be included. All of them will not be included because combined returns has only 1256. And if you only wish to include those that are present in both of them, then what will happen is that some of the dates, some of the observations in the longer data risk-free rate daily will not be included. Okay, so let's run this class. CAPM, Control Enter. CAPM data, and it's still an XS object. Okay, and let's check. So we now have merged Apple returns, SPY returns, and RF rate. Notice it's now 1256. RF rate was 1305. Okay, and what happened was it followed what was present in Apple and SPY returns. Okay, so that's what this all is equal to false mean. Okay, so let's check if there's NA here. Let's do sum is dot NA and then CAPM underscore data. Okay, let's see. Okay, so there are 9. 9. Okay, so in order to remove class, you can use CAPM data NA.omit. So let's run this and see if there's still NA here. Okay, wala na, no? So it removed the NA and A values there. Okay, let me pause for a while and okay, let me pause for a while and seek your feedback, your comments, class, if you're able to follow. So were you able to generate the CAPM data with no missing values? Okay, only 3 respondents. Let's wait for the others. Okay, good. Okay, thank you. Okay, so quick review. We now have CAPM data. It contains Apple returns, SPY returns, and the risk-free rate. So we can now, okay, we can now calculate excess returns. What we need is Apple returns excess and SPY excess returns. Okay, we don't need their returns per se, but the excess returns. So let's first create an object called Apple excess returns. And how do we generate this? It's from the CAPM data, Apple returns, minus CAPM data, risk-free rate. So we're going to subtract Apple returns minus the risk-free rate. When we do that, we're creating the excess returns. Okay, and then we're going to convert it into as numeric. So which means this is XTS, this is XTS, but when we convert it as that numeric, then it will become just a simple, since we're getting the difference, then it will be all values, quantitative values. So this will become a vector. Same thing for SPY returns class, as that numeric CAPM. Okay, I'll no, I want you to write this class. Please write the code. I'm going to give you a few seconds to write that code. And when you're done, class, kindly please chat. Thank you. So let's wait for the others. Good. Let's give your classmates a few more seconds to make sure that they're on the same page as us. If you run this class, this should appear in the values because this is just a vector of excess returns. Okay, because we converted it into as.numeric. So this becomes a vector. It will not be found in your data, but rather in your values. So if I show this to you, here under my values, you have here Apple excess returns, okay, and SPY excess returns. Okay, good, thank you. And then what we're going to do now is, okay, this one, I'm going to just share this with you in the interest of time. Insert it in your code. Okay. My question dito si Moises, no? Bakit kailangan i-convert into numeric? Okay. In passing, I said a while ago that when we do LM, we will have to create a data frame. Okay, so hindi pa pwedeng XTS object. When you do LM, it will not work if your data is an XTS object. So first, we're creating just a vector of numbers. And then we will put this together here. Ito na, no? Ito na tayo. So this is to answer the question of Moises, a very good question. I'm now creating CAPM regression data frame, and then here. So I need a vector of excess returns in order to create my data frame. So here I'm creating a column. Okay, I'm creating a variable called apple.excess, which is your apple excess returns. How did we get apple excess returns? It's your apple returns minus your risk-free rate. So this is your excess returns. Okay, apple returns minus risk-free rate. And this is a vector, and then I'm going to use that here. Okay, so that's the reason, Moises, now why I'm converting it into a numeric so that I can create a data frame. Okay, data frame. This is a vector. I'm including it here, and this also is a vector. Okay, thank you, Moises, for that very excellent question. Did that answer your question?
Yes po, sir. Thank you.
Good. Thank you. All right. So now we have this object class, CAPM regression data frame. What does it consist of? Does it contain two columns? The first column is apple.xs. That's the name of the column. The second is spy.xs. That's also the name of the column. And let's print the column names. Okay. And then also make sure that na.omit, no? Baka may mga na values tayo dito. Okay, so let's run this one. Okay, and you can see that the column names of CAPM regression DF is apple excess and spy excess. Okay, let's take a look at your object CAPM regression DF. Okay, here, no? Here. Okay, so we now have apple excess and spy excess. So what are we doing? Why are we doing this class? Because we're going to regress apple excess on spy excess. And that's your CAPM class. Okay. Excess returns regressed on market returns. All right. So we're now ready, class. If we get the structure of the CAPM regression DF, it's a data frame consisting of 1247 observations and two variables. Okay. This one, class, is an alternative. I'll just share this with you. Okay. Okay. Let's discuss this, class. Kasi before I discuss this, okay, let me just show you something. Okay, let's use this class. CAPM, what's that? CAPM data. Okay, here. CAPM data. So if I check the structure of CAPM data, no, not that CAPM, not CAPM data, but CAPM. What did we use a while ago? No, combined returns. I'm sorry, combined returns. Combined returns. XS object. All right, so it's an XS object class containing your apple returns and spy returns, right? So let's see head. Let's just get the head of combined returns. Just get the first three. Okay. So as you know, class, an XS object will contain the index as the date, and then you have here whatever object you have, the returns or the prices. Now, an XS object class has two parts, the index and the data. If I get, class, the core data, core data of my combined returns. So the core data class allows us to get this. So let me just get the head of this, head of my, just the first two. So I'm getting the core data of what? Of my XTS object called combined returns. And I'm just getting the first two observations. Control Enter. Notice that it will give us the data itself. Okay. The data is Apple returns and SPY returns. So the first two. Or if you want, okay, arrow up. The other part is the index class, index. Okay, so the XS object has two parts, the core data and the index. So I control enter. Notice that it gives us the dates. Okay, index will give us the dates and core data will give us the data itself. So in this code class, the alternative, which we will not run anymore, okay, I will ask you to study it. So we're generating this XS object, and it's coming from Apple returns minus risk-free rate. Okay, so this is an XS object minus an XS object. This will now generate an XS object. Same thing with SPY returns. Okay, so what I'm going to do now here is I'm going to create a data frame, and here data.frame, and notice what did I do? I use the core data. Okay, core data of this object. This object is an XS object. It has a core data. Okay, same thing here. Okay, and if I print the columns, I'll get also Apple access returns. Okay, so this is just an alternative Control C to the one above here. Now this is more simple class. So here we did first as that numeric. Here we directly use the core data and the not the index because we don't need that. Control V. All right. So I'll leave you class to run this. You'll get the same thing anyway. I just made sure that the CAPM regression DF1, okay? Because the first one that we created is CAPM regression DF, just to distinguish it. Okay. All right. So if you try to run it class, you'll get the same thing. You'll get an object that's called CAPM regression data frame, and it's a data frame containing Apple access and SPY access, which is what we need. All right, so let's now move on here, class. Let's now create our model, LM class, LM Apple access regress on SPY access. What's the difference between this one and the first one that we created above last meeting? Last meeting, we were regressing Apple returns from SPY returns. Okay, technically that's not your CAPM model because we're not using the excess returns. Here, we're staying true to the CAPM model, where what we are modeling is the excess returns of the asset and using the excess returns of the market. Okay, and then let's use LM and let's run this. Okay, for this one, I just want you to write it on your own. Okay, and run. There you go. So what do we have here? This is your Jensen's alpha, your slope intercept, and this one is your SPY.XS. And it's also statistically significant this one, the intercept, is also not statistically significant. And the multiple R squared here is 6296. A while ago, it was, I think, 6218. So higher multiple R squared here. Not that much the difference between the one that where we use only the returns and not the excess returns. And the beta 1.86. Okay, it's practically the same as the other one. The other one was 1.89, right? This is 1.86. So still the same. Okay, 1.86. Your Apple stock is very volatile, very sensitive compared to the market. Okay, kasi si Apple growth stock yan eh. Okay, so 1.86. Okay, or this is actually 1.19 also, no, 1.19. The one a while ago is 1.89, I think, or 1.88. This is 1.186. So for every 1% increase in your market, as proxied by your SPY excess, 1% increase in your excess returns of the market, you'll have a around 1.19, also 1.19% increase in the excess returns of your asset. Okay, so practically the same. Okay, not so much difference. Partly because our date is quite limited. Limited din yung date natin. Okay. So I'll just share this with you. We can now print the CAPM results. Okay, here. So we first compute for the beta. Okay, and we can get it from a function called CAPM. Let's first take a look at CAPM model class. What's CAPM model? This is the regression model that we generated here. And if you take a look at this, it has class. It's just like the LM model that we generated before. Okay, you have the coefficient here, the coefficient, intercept, and SPY excess. You have here your residuals, your fitted values, etc. Okay, so if you want to get the coefficients, okay, so you can use the COEF function, or you can use the CAPM model dollar coefficients and then get the intercept. So let me just show you. So CAPM model, okay, dollar. So coefficients, okay. So this is our coefficients class, no? And then we can subset intercept. So the name of the intercept has parentheses, intercept, close parentheses. There, we can access this class. We can access the coefficients there. Control Enter. So that's your 0.0031, right? Or we can access the same. Let's replace this with, that name is spy.access, spy. Make sure you have the correct spelling. Access there. Spy.access. Control Enter. And this is the one. Okay. You can actually also get, let's take a look at this one class here. What if we want to get this one, the probability of SPY excess? Okay, same thing class, same thing. So I'll copy that one. Okay, CAPM, coefficient SPY excess, and then I want to get here. Okay, let me copy this. Control C. Let me check if this is the syntax. Tama ba to? Okay, this one, this column. The probability Okay, incorrect daw. So wait. Do I need this? Wait, huh? Okay, later. We'll get that class. I'll just try to recall, no? What I'm saying here is that you can access anything here, class. You can access anything here. Okay, okay, let me see. Okay, so this one, let me share this with you. Control C. Have I shared this with you? Yeah, I shared this with you already. Okay, so if you run this, so what this will, first it computes for the beta apple. It gets it. You can use this one that we used a while ago, a CAPM CAPM underscore model dollar, or you can use the function coef. That's for coefficients of the CAPM model, and then subset spy dot xs. Okay, so from the coefficients, you can get this spy dot xs, and then the intercept. Or you can use the one that I used a while ago here. It's also possible. Okay, and then let's print. Title is CAPM beta and alpha for Apple. Okay, close it. And then Apple beta sensitivity to spy, 4 decimal places. Apple alpha excess returns, 6 decimal places, because the alpha is quite a low number. So here, class, we were able to print this one. Apple beta sensitivity to spy is 1.1865, and the alpha, which is your intercept, is 0.00310. Okay, tama naman ako. Sorry. Hindi pala dun sa ano. It has to be from the summary class. Okay. So this is where I got it wrong. I'll share this. Control C. And I wanted to show you that you can get also the other parts, not from the CAPM model, but from the summary of the CAPM model. So take a look at this class. Alpha p-value. So how do I get the p-value? Okay, you get the summary class, the summary of the CAPM model. Okay, not the CAPM model. So summary of the CAPM model, because the summary class, okay, here, the summary contains this one. Okay, it is in your summary. Here, class. But this is your summary, this one. So you have to use this summary of your CAPM model. Okay, and then coefficients, let's say spy access, and then get the probability. Okay, so that's what we're doing here. Here, class, okay? Summary of the CAPM model, and then coefficients, and then bracket intercept, and then the p-value. Okay, so this is how you get the p-value from the table itself. And then print alpha p-value, 4 decimal places, comma, and then the value. And then let's write whether it's significant or not. If alpha p-value is less than 0.005, then concatenate alpha is statistically significant. Otherwise, alpha is not statistically significant. And if you run this class, you get this. It identifies the alpha. This is the alpha p-value here. And then the value is here. Alpha p-value 0.3666. And then alpha is not statistically significant. Okay, so I hope you're getting more familiar with printing, using the value of your object, putting it in your text, just like this one. Okay, let me pause for a while and ask you, class, for feedback. If you were able to follow. Okay, good. Okay, so, all right. So what did we do here, class? We computed for the excess returns of your asset. Okay. Take note, class, that the excess returns of your asset is not just one value. Huh? It's throughout the saan na siya? Where's our object? CAPM model. CAPM model. Okay. You might be mistaken into thinking that there's only one predicted value here, class. Here. So these are your predicted values of your predicted excess returns of your asset based on the model. You also have 1247, okay, 1247 values. Okay, is there another way to compute this, not using LM? Yes, we can use class can use performance analytics. Okay, performance analytics, on the other hand, require that we should have the asset returns as an XTS object, the benchmark or the market excess returns, and the risk-free rate, XS objects. So we have those. If you recall, plus yung ano natin, yung here, Apple XTS excess, XS object yan. Pati yung SPY XS excess. We have those. So let's check first, and I would want you to type this, class. Okay, for this one, I'm just going to share this. Text lang naman to eh. Okay. So we expect to have this same results, class, as the LM model. I'll tell you the difference between the performance analytics and your LM model. Okay, so let's first check if Apple excess returns XTS. No? I think sorry, I think we simplified this. Yeah, okay, because it's too long. Asa na ba siya? Plus, I think Apple XTS. There. Okay, same thing, di ba? We just SPY XTS underscore excess there. Haba kasi ng pangalan. Ay, mali. Ito na pala yung class. Sorry, class. Sorry. I got ahead of myself, no? Okay. Here is where I changed the name, class. So this one we created a while ago. This is an XTS object, which is what we need for performance analytics. Okay. So you notice, class, that we're navigating between two types of data. We have an XTS object and we have a data frame. For the LM function, we have to use a data frame. But for the performance analytics, what's required is an XTS object. And we created this a while ago already. We have this. And then just create this class. Okay, I'll not share this with you. You can just, it's very easy to run. Okay, I'm changing the name so that because it's too long. So I have this already. I won't run it anymore. You don't have it because what you have is Apple excess return. So make sure you run that. Okay, when you're done, class, kindly please chat. I need around 10 minutes for the introduction to Fama and French. Thank you. Thank you, Adrian. How about the others, please? You don't actually need this class, but I just want shorter name kasi masyadong mahaba eh. Okay. All right. Okay, good. Thank you. Okay, so this one. Okay, sige, you write it, class. You write it. So what are we doing here? We're using CAPM.beta. This is a function coming from performance analytics, and it will compute for us the beta, the 1.18 here, this one, 1.8, 1.186. Okay, so we can compute it directly using performance analytics instead of using the LM. Okay, so it's a function CAPM.beta. Then we have to identify the RA. That's the excess returns of the asset. And this is it, class. Apple excess, XSX, excess. Make sure it's an XS object class because this will not work if your object is not an XS object. Also, R sub B is your market excess returns, SPY XS excess, and then your risk-free rate. Our risk-free rate class, we can get it from CAPM data. Remember, CAPM data has Apple returns, SPY returns, and RF dot rate. So we can get the RF dot rate. Okay. And then, so we name it CAPM beta performance analytics, PA. And then also CAPM alpha, PA. And the function is CAPM.alpha. Ganun din class yung requirement. So the only difference is CAPM.beta and then the CAPM.alpha. Okay, and then we're printing it here. Concatenate. The title is CAPM beta and alpha for Apple from performance analytics. And then print Apple beta, 4 decimal places, comma, the result here. And then print Apple alpha, 6 decimal places, the result coming from this one. Okay, so I'll ask you to run that class and tell me what happened. Did you get the same values as the LM function above? Should be getting 0.0003 something and 1.186 something. Please chat, class, in the chat box, class, if you got the exactly the same answer. Are we validating now the CAPM.beta function of performance analytics? This one, class, okay. Sorry, this one I'll just share it with you, class, to say it's quite long. But the other one, this one, I want you to write it for familiarity with the CAPM.beta and CAPM.alpha function. Okay, good. Thank you. Thank you, Aiden. Let's see the others. I'm gonna, if unless you had some errors with your Apple XS access, okay, it should be the same class. How about the others? Okay, good. Yeah, thank you. All right. Thank you so much. Yeah, I'll run this also. And then, so title, CAPM beta and alpha for Apple from Performance Analytics. It's the title here. Apple beta 1.1867, 4 decimal places. Apple alpha 6 decimal places, 0.66329. Okay. All right. So we got the same answer, class. Only my note here is that LM class provides us with a rich information, class. Because it's an LM object. Okay. So unlike the performance analytics, if you check your CAPM beta PA, it will be under the values class. So it's a singular vector lang siya, no? This is just one value, CAPM, this object. Check your environment and you'll see that with your values. So isa lang siya. Okay, so if you just want a quick value and you're not really, you don't want to get the other regression details, then you can choose CAPM.beta. But if you want further analysis and you want to extract more insights, then you use the LM function. All right. So let me pause there. Clear so far, class, before we go on to the next one? Clear so far? Okay, good. Thank you so much. Okay, thank you so much for the quick response. Okay, I appreciate that. All right, so what we have done so far is CAPM. In case, class, I extend a bit, just go ahead and you may exit the room, class, just for purposes of recording. I'll extend a bit. I think I'll need a few minute extension. Okay, but the problem is, class, the regressor that we're using there is just the market. Okay, so enter, class, the Fama and French model. The Fama and French model, where we use other factors and reinforce it with the excess returns of the market in order to model our excess asset returns. Okay, so may I ask you, class, kindly Google it, class, and tell me what are the factors that are used in FF, Fama French. Before that, class, may I ask you, class, if you did you discuss Fama French, the 3-factor model or the 5-factor model in your other subjects before this? Kindly, please. I just want to be apprised if you discussed this before. 3-factor Fama French, 5-factor Fama French. Yes or no lang, class, please? No? Okay, good. Okay, that's good because this is an opportunity for us to learn not only Fama French, but also computing it using the R context. So this is something that's very good application of regression model. Regression pa rin ang gagamit. We're still going to use regression. However, it will now be multiple linear regression. Because what we have been using so far is CAPM, that's simple linear regression. You have a singular predictor, you have market excess returns. Now we're going to incorporate the other factors. So tell me what other factors are included in the Fama French model class. Kindly, please. And good. Thank you, Moises. You have market excess returns. So take a look at what Moises posted here. Okay. Then we have here the SMB here. SMB. This is your SMB. Small minus your big, okay? Small minus your big assets. And then we have here HML, HML. The high market value, okay, minus your low market values. Okay. Can you give me two more, please? Two more. So this is used now for, this is your three-factor class. Market excess returns, SNB, HML. How about for your five-factor models? What's to be added there? There are two more, class. And yeah, correct. Thank you, Aiden. You have RMW. Yeah, thank you, Paula. RMW and CMA. What does R stand for, class? What does R stand for? R and W, C and A, class. The M there stands for minus, class. So what Fama and French did was to subtract your, let's say, your SMB, small assets, and then minus your big assets. Yung returns nila, no? So that will be considered as a factor. Okay, RMW, class. Anyone can give the meaning of R? Okay, robust minus weak, and then CMA. CMA, class. What's CMA? There, thank you. Conservative minus aggressive. So what Fama and French did was to compare small and big, high market value or high book value minus the low, okay? And then we have the RMW, robust minus weak, and then we have the conservative minus aggressive. So these four factors together with the market excess returns, okay? So you now have five factors. The three factors will only include market excess returns, SNB, and HML. The five factors will include the RMW and the CMA also. Okay? So that's what we're going to do. Now, where do we get that data? Okay, so let me go here. Please go to this site. Okay. I'll first share the site because we might run out of time. Okay, this one first. Control C, Control V. Okay, go there, class, please. And take a look at, you'll be led to this one. So kindly look for the meaning of CRSP. That's very easy to know, class. CRSP. Okay, I'll leave that for you to find out, class. The old method was the FIZ method. Okay, historical data based on the legacy method FIZ. Now they're using CIZ. So what do we find here, class? Here you can find Fama and French 3. So what's Fama and French 3, class? These are three factors. You have here the excess market, small minus big, and high minus low. Then you have here the most recent. Okay, this is the excess return of the market, 1.98. And then the small minus big is 0.27. And then HML, negative 1.26. And if you take a look at the last 3 months and the last 12 months. Okay, so this is now below here. You have your five factor 2 by 3. You have the first three, which is your 3-factor, and then included yung, okay, yung RMW at saka yung CMA. Okay, and then we have other factors here, class. Small value, okay, small neutral, and small growth. Big value, big neutral, and big growth, etc. Okay, and then here, class, this is where we get the data. So Fama French, 3 factors. Meron tayong weekly dito. We have daily here. This is monthly. We're going to use monthly, class, because if you in practice, the monthly data is used. Okay, we're going to download the 2x3 because the 2x3 already includes the 3 factors. Okay, so we can download daily data class. You can practice on this, or you can use here. This is monthly data. So click CSV here, click, and then I suggest you save it in your R project class. Okay. By the way, I hope you already created a new R project for regression. Okay, I think I forgot to tell you about it because the first lesson was not about, it was more visualization, returns, portfolio returns, etc. Okay, so please save it in your R project. It should automatically save there because I hope you're working inside your project. So when you save this class, take note this is a zip file. Okay, zip file. I will not save that anymore. But once you save it, class, please extract the value. Okay, so extract the value of this one, class. When you extract it, it will create a folder. Okay, and inside that folder, class, is your CSV file. Oops, sorry. Okay, because I already removed that a while ago. Okay, inside that folder, class, is your CSV file, and then remove that. Okay, wala na dito. Remove that, class, from your okay, here. Remove that, copy that, and then copy it in your main, not inside the folder, but in your main R project file. Okay, so you'll be able to, you should see this, class. Okay, FF research data 5 factors 2x3. Okay, and then I will require you, class, to look at that, study that data, and see what you find there. Now, in the interest of time, I will have to share this now with you. So what we're going to do is we're going to choose some assets that we're going to do some we're going to model these assets, and I'm choosing these assets for a particular purpose. So I'll Control V. Okay, sorry, doesn't fit. Okay, there. So what are these assets, class? So I'm choosing small cap exchange traded funds. Okay, so these are small cap. So you will notice that when we run this, the small cap here will reflect in our SMB. Okay, so small caps, the asset is IWM. These are iShares Russell 2000 exchange traded funds. These are small capitalized assets. So it's expected to have a high SMB. Okay, high SMB size exposure should be positive, and possibly different value profitability profile than S&P 500. Okay, next is the value growth. This is IWF, also Russell 1000 growth exchange traded funds. So these are 1,000 stocks. Okay, Fama and Friends got the returns of this 1,000 stocks, growth stocks. Also sector, class, XLK, technology sector, and then we also do financials, and then smart beta. Okay, these are high profitability exposure. And then another one, please read on this, and then I'm choosing just an individual stock, Tesla. Okay, also an international exchange traded fund. Now, my question is, what makes this asset interesting for Fama French analysis, of course? Because their betas are non-market, okay, which means that their betas are not equal to 1. Okay, they're very far from 1. So either they're very small, okay, less than 1, or they're greater than 1. So they have also significant S&B, HML, RMW, and CMA exposures. Okay, this shows that they tilt to factors beyond the market. Okay, because remember, we're now doing 3-factor and 5-factor. We'll start with 3-factor first. And now we will see that outside the effect of the market, we will see what's the effect of the small cap, small minus big, HML, and the RMW and the CMW, CMA. Okay. All right. So let's do this next meeting, class. We're going to use quant mode in order to get the assets and get the returns of the assets. Okay. So that's it for now, class. Okay. So may I ask you, class, if you learned something today, class? I hope you learned something today.